Okay, so this question is a little involved. There's a proper way to do it, and then there's a cheating way to do it. Okay, so let me show you the proper way first. We need to make up a 500 ml of a buffer containing this for stock solutions. Okay, so let's just focus on the stock solutions first. What this is saying is that we need in the end a buffer, and this buffer volume will be 500 mils, and in this 500 mils there will be 50 millimolar tris, 5 millimolar magnesium chloride, and 1 millimolar EDTA. Okay, so in this buffer, this means there needs to be that concentration of these three different species. Currently available to us, we have these stock solutions. Okay, so we have 0.5 molar tris, we have 100 millimolar magnesium chloride, and we have 20 millimolar EDTA. Okay, so the first thing to do, I think, is to actually work out, take from concentrations and actually work out how many moles or how many millimoles of each of these species we need in our final, and then we can figure out how much of these stocks we need to take out to deliver this number of millimoles or moles into our final. Okay, so for our tris, we need 50 millimolar. 50 millimolar is expressed as 50 millimoles per liter. So if we had or needed 1 liter, okay, we would need or we would have 50 millimoles of the tris. We don't need 1 liter, we need 500 milliliters, which is the equivalent to 0.5 liters. Okay, so 0.5 liters to get from there to there, divide by 2, get from there to there, divide by 2, which means 25 millimoles. Okay, so in here we actually need 25 millimoles of the tris. Of the MgCl2, 5 millimolar is equal to 5 millimoles per liter, which is 2.5 millimoles per 0.5 liters. Okay, so we need 2.5 millimoles of MgCl2 in this final buffer. For EDTA, we need 1 millimolar, which is equal to 1 millimole per liter, which is equal to 0.5 millimoles per 0.5 liters. So again, we need 0.5 millimoles of EDTA floating around inside that final buffer. Okay, so how do we get 25 millimoles of tris in there? How do we get 2.5 millimoles of MgCl2, and how do we get 0.5 millimoles of EDTA into that final buffer? Okay, so we have these stocks available to us. So 0.5 molar of tris, 100 millimolar of MgCl2, and also 20 millimolar of the EDTA. Let's think about the tris. Okay, so the tris, we have 0.5 molar, and we may have purchased this tris from a manufacturer or something, and so on the bottle that comes from the truck, you may have written on it 0.5 molar. Okay, so we need to figure out how much of this 0.5 molar solution we need to take out in order to give us this 25 millimoles of the tris. Okay, so 0.5 molar can be expressed as 0.5 moles per liter. 0.5 moles per liter, okay, 1 mole is 1,000 millimoles, which means 0.5 moles is 500 millimoles. Okay, so 500 millimoles per liter. It's essentially the same as saying 0.5 molar. Okay, so this means that in our stock, or from our stock, if we took out 1 liter, remember there's an invisible one there, if we took out 1 liter of our stock, we would be taking out 500 millimoles. We don't want 500 millimoles though, we want 25 millimoles. Okay, so 25 millimoles in how many liters? Well, to get from 500 down to 25, you have to divide by 20. Therefore, to get from 1 down to whatever it is, you also divide by 20. Okay, so this would be 0.05 liters. Okay, so this means that in order to deliver 25 millimoles of tris, we need to take out 0.05 liters in order to get that 25 millimoles. Okay, this 0.05 liters can be alternatively written as 50 milliliters. Okay, so if we take out 50 milliliters, let's rewrite that again, milliliters of our stock solution, will be in those 50 milliliters will be 25 millimoles, and that's all we need to deliver into our big beaker in order to get 25 millimoles in there. Okay, now for our MgCl2 and our EDTA, the calculations are essentially the same. So I want you to try and do these calculations. The answers here, let me just work them out quickly. 20, okay, so the MgCl2, you should end up needing 50 milliliters as well of the stock. And this one, you should end up needing, oh no, sorry, that should be 25 milliliters. Okay, I forgot it's a 500 final. And this other one, you should also need 25 milliliters of the 20 millimolar EDTA stock. Okay, and the calculations used to get to those answers should be the same calculations as you've done here. So this is the proper way of doing it. Now, if you want to know the quick way of doing it, and the quick way is nice if you know exactly what you're doing. If you don't know what you're doing, or if you're not too comfortable with these calculations, it's best to go through this gradual calculation process. Okay. The other way of doing this calculation, if you're interested, is the X factor method, or the dilution factor method. Okay. Let me just rub out some of this. Okay, so for the trick way, what we can do is we can say our stock solution of tris, okay, is 0.5 molar. This is the same as saying 500 millimolar. Okay, now 500 millimolar, and what we need of the tris is actually 50 millimolar. What you notice is that the 50 and the 500, okay, there's 10 times in it, okay, which actually means that this stock of 500 millimolar is 10 times more concentrated than the final stock or final solution that we need. It's like if you're working at Macca's or something and you're making Coke for your customers to drink. You don't, put, what you do is you have stock Coke, and then you add a bit of this stock Coke to a lot of water, and you end up with the right amount of Coke flavor inside your solution. Now, what this is saying is that because the stock is 10 times more concentrated than what you need, you need to dilute it by 10 times. Okay, I'll say that again. Because the stock is 10 times more concentrated than what you need to dilute it by 10 times. Now, to do this 10 times dilution, okay, or a 1 in 10 dilution, so a 10 times dilution, also known as a 1 in 10 dilution. Okay, this means that you have one part out of 10, which is your stock, and 9 parts are the water or whatever else there is. Okay, so if there are 10 parts and your final volume is 500 mils, okay, each part is 50 mils. Okay, 10 parts makes 500 mils. One part is going to be 500 divided by 10, which is 50. Okay, which is why you need 50 mils back over here. Okay, let's try that calculation for the MgCl2 as well as the EDTA. Okay, so for your MgCl2, our stock MgCl2 is 100 millimolar, okay, And what we need is, we need 5 millimolar. What you notice in here is that 5 to 100, there's 20 times in it, okay? Which means we need to do a 20 times dilution, also known as a 1 in 20 dilution. This means that 20 parts all up, okay, 1 part is going to be your stock, okay, and 19 parts is going to be everything else inside that solution. Okay, so there's 20 parts out of 500 mils, okay. This means that 1 part, so 500 mils, and if there's 20 parts, this means that 1 part is 500 on 20, which is 25 mils, okay. So 1 part of this stock, 25 mils of this stock, 25 mils of this stock. And also for the EDTA, if you do the same calculation, it'll come out also to be a 20 times dilution, which will also mean 25 mils of this EDTA. So this last method, this dilution factor method, is quick, but it works. You have to be careful when you apply it. It doesn't work all the time because sometimes the numbers are a bit weird or a bit ugly, and you may get lost in your 20 times or something. So I do recommend that you use the method that we showed before, the longer method, because it's more foolproof. This way is quick, but it's very prone to error, so I don't recommend using this method.